Hi, everyone. Eric, should I?
Hello and I speak a little louder than possible. Hello and welcome to Pandora. I'm Eric Vishke, Chief Scientist here. Glad you all could make it all the way to East Bay. So this is our intergalactic HQ. You probably found the pizza in the back, bathrooms over here, drinks in the corner, anything else you need, feel free to ask anybody. We've got a pretty sweet lineup. The panel's going to be pretty fantastic. Just a few things. We've been on this block, literally one block. Pandora's been here for the last 13 years, so we've been like Oakland for a super long time, which is exciting. We were in San Francisco for about a year, and then we've been East Bay since then. We're always hiring data people, scientists, researchers, machine learning people, recommender systems people specialize in ads. We like to play ads, we like to play awesome music. Those are the things we do. My background, I actually started at Cal, I guess it was 14 years ago. I was studying econ and poli-sci, and the dot-com boom thing was happening, and I was like, hey, you know what? I could pay for my college education in one swoop if I could hit one of these dot-com companies. So I was sold on the idea of 3 months in IPO, which was the thing I dropped out of college to do. That didn't happen. It took 11 years and 3 months, but it wound up happening, which was kind of exciting. It's been a really fun journey. Our first sort of 4 years after we started the company in March of 2000 was really struggling to find a kind of a business plan. We tried dozens of different business plans and ideas and built different products from the ground up. So we were kind of in incubator land over and over and over and over for those first 4 years. And then in 2004, we hired a new CEO. His name was Joe Kennedy. And him and Tom Conrad kind of came up with this idea of online radio. Before then, we didn't really have any idea what the product that was going to kind of work, connect with people. And so that was a really exciting moment for us. And so it's fun now to kind of hang out with you guys and kind of think about that. For us, we literally started up for years before we had something that actually worked. And then as quickly after we launched our radio product, it was pretty clear to us that pretty much everyone we were sharing kind of this new online radio experience with liked it. And we're like, hey, okay, we think we found our business plan. When we launched, we were actually a for-pay service only. Our board of directors, the day after we launched, held a board meeting and was like, we need to make this an ad-supported free product as quickly as possible. At the time, that totally did not seem clear whether that monetization strategy would ever work out. So it's interesting for me to kind of reflect on how the kind of startup world works, where you just try things, and then something finally sticks. That's kind of the path that Pandora took. My role, basically, right after we launched the online radio product, I was sort of an all-purpose engineer. And then in that year, basically, I started specializing on I'm just going to work on the problem of how do we play awesome music for people. And I was a college dropout at that point. I was trained in econ and poli-sci, but for some reason, the people here trusted me to figure out how to play great music. Since then, we've built up a pretty massive research team. You'll hear from Oscar Selma, who's our director of research, a bit later. He now runs all of that. Now I just take credit for all of the work that him and his team do. And today, kind of our research kind of in data science land, data-driven land, kind of revolves around basically two things. One is how do we play awesome music for people? That is, as best I can tell, an unsolvable problem. We could always play better music for people. One of the primary ways we do that is through huge amounts of sort of data processing and data analysis in all sorts of different ways. And I'm sure Oscar can and will talk about that at length. And then the other thing we do with data is the advertising side. And in many ways, what Pandora does, we're the second biggest mobile advertiser in the United States. That's lots and lots of advertising. And what's really unique here is that we're sort of the new generation of sort of audio advertising on the internet. There's not really like there's other players in the United States, but all of them combined are a fourth the size of Pandora. So we're really here trying to figure out how do we use data to do audio advertising in sort of the modern era. And those are kind of the big things we're working here on the data side. So anyways, that's a little bit of kind of the story arc here of Pandora. I'll be around after if anyone has questions and stuff. But with no further ado, I'd like to introduce Pashu from the Hive.
Thank you. Thanks. Thanks so much for having us, Pandora, Eric. Who did read Jordan's Novet article that was published yesterday on VentureBeat? Anyone? Great. You did your homework. Thank you. So it's posted on the event page in case you haven't read it. It's on deep learning and music streaming, so it's a great way to learn a little bit more about what Pandora, Google, and other companies are doing in machine learning. My name is Pashu Christensen. I'm the Marketing and Partnership Manager for the Hive. And I'll say a few words about the Hive think tank, but first I'd like to know who knew about the Hive think tank tonight before coming here? Anyone? Yeah, a few ones? Okay, great. So it's our first event here in Oakland. We usually host our events in the South Bay and in San Francisco. So the Hive think tank is a community of data scientists, engineers, practitioners, developers, designers, artists, all focus on big data, and we host events every week, every Wednesday evening on anything related to big data, from machine learning, infrastructure, Hadoop, data science, all the way to retail and environment. So we cover a lot of topics related to big data. We hosted over 60 events in less than 2 years. We have 6,000 members, and you are part of the community now, so which makes of the Hive think tank one of the largest data-driven community in the US. And we hosted over 150 speakers. These are our upcoming events. So we usually host events every week, but because December is a little, we have all these Christmas parties and all that, so we are slowing down a little bit in December, but we'll be back in January with events every week. We'd like to thank our sponsors tonight. You might know them, and our partners, and of course we'd like to thank Pandora for hosting us. If any one of you use Twitter, please continue the conversation online using the hashtag HiveData, take pictures, comment, and we love to continue the conversation online. With that, I'm going to pass the microphone to TM Ravi, who is the founder of the Hive. Thank you.
And thanks to the folks at Pandora. This is the first event I think we're having in the East Bay.
Yeah.
So hopefully just the beginning. And so welcome, and so I'll give you a brief overview of the Hive. So the Hive has two parts. One is an investment arm. We are an early stage venture capital structure focused on big data. And we don't do any infrastructure, so you won't see us invest in the next Hadoop killer or a Spark killer or something like that. But rather we are investing in applications and use cases of data, in advertising, in e-commerce, and ad tech, and payments, and so on and so forth. And we engage with entrepreneurs very early, one guy, one girl, and a dog type of situation, and then work closely with them. So we have a CTO, chief architect, professionals on the online side, professionals on the enterprise side. So that's what we basically do. Those are our investments that we've made since September of 2012 in ad tech, in mobile retargeting. Jobber is Tinder for jobs, Internet of Things, and so on and so forth. So we are hiring like everyone else. In this case, we are looking for awesome software engineers for an Internet of Things company that we've just started. This company enables application development for complex IoT deployments. And so we're looking for product management, director of product management, a bunch of engineers, and today, if you can use the hashtag HiveData, so people can listen to what you're saying, and we would appreciate if you can go and check us out on Facebook. So you will see after the event that we will post a video and on YouTube, and a bunch of pictures and all that information you can find on our social media. So with that, I'll hand it back to Pasha.
Great, thank you. I'll just briefly introduce the speakers. So we have Jordan from VentureBeat, please come on stage. David from WoodSnap, Jennifer from Soundhound, and Oscar from Pandora, of course. Oh, sorry about that. So you have this one. And your shadows.
David, are you already sharing the mic with me?
Sure, let's do it. I don't know what I'm signing up for, but all right.
Okay. Well, I'm really happy to be here tonight. I'm Jordan from VentureBeat, and I'm the nerdy one on the VentureBeat writing staff. I write about cloud infrastructure and big data and quote-unquote enterprise, whatever that is. And I am really thrilled to be here with awesome people. We had a prep call last week, and we had a lot of ideas. And I wish we could have had more time to talk. Fortunately, we have this panel. So I'm sure we'll have a lot to talk about. And I'm looking forward to having that feeling where you've been on a panel so long and you want more time to have the panel continue. So we'll see if my panelists are able to make that happen.
We're off to a good start. So I'll just, I guess, do a quick introduction here. I'm David Blutenthal. I'm the founder and CEO of MoodSnap. We're a Boston-based music tech startup. We are essentially a mood and activity-based internet radio app. And the way that we very uniquely capture mood is through images. So what we do is we categorize music stations by very emotive photographs, such as someone sitting in a coffee shop on a rainy day with rain coming down the window, or a young couple in love in Central Park. And so that image is the inspiration for a co-curated music station. So we are a socially curated experience that gives the users, access for creativity if you're sort of a lean forward curator, but also a very simple and passive lean back listening experience. So it's really as easy as tapping an image that feels right to hear music that feels right. Our goal is to make the music discovery process much more emotionally connected and doing less work thinking to find what you're looking for. My background before this is in artist management. For about 7 years. I ran a record label in Chicago for a little while, and this is actually the fourth music app that I have led, I shouldn't say led development on, because I'm fairly non-technical. I'm more of the product leader and marketing brain behind it. But we have a series of set list and statistics-based apps for Bruce Springsteen, Fish, and the Grateful Dead, and Dave Matthews Band, if you want to have every set list in your pocket and all these fun ways to geek out over stats of when the last time somebody played something was and stuff like that. We've got those on iOS too. So I'm really honored to be here with everybody today and looking forward to seeing how this takes shape.
Hey, hi. I'm Oscar Selma. I'm the Director of Research here at Pandora. So I was supposed to introduce what's Pandora, but I think it doesn't make that much sense. But maybe I can tell you guys what Pandora is not. So I'm originally from Spain, and anytime I fly to Barcelona to see my parents, I'm at customs at the airport, and like, okay, you're now based in San Francisco, that's cool, so what do you do there? And I tell them, well, I work at Pandora. They're like, okay, the jewelry company. I'm like, Yeah, the jewelry company. Then I have some family in Mexico City as well. So every time I go to Mexico City, yeah, of course, I go to customs and they're like, what do you do for living in San Francisco? I'm from Oakland. And then, yeah, I work at Pandora, and actually there's a huge Pandora Mexican band from the 80s. Yeah, 3 girls.
Is there music on Pandora?
Yeah, there, yeah. So yeah, so it's like, oh, are you the manager of the Pandora band? I'm like, yes, I'm the manager of the Pandora. So, but I'm really happy to be part of the real Pandora here in the US. Yeah, so I'm director of research. I mean, Eric gave an awesome presentation of the work we do here. I mainly manage a team of scientists that do a great job here. My background is I did a PhD back then in Barcelona in computer science. My topic was on music recommendation and discovery, so I think it's a good fit for me now being part of Pandora and being able to not do any more Python or just like lead the team and let them do the great job.
Hi, I'm Jennifer Kennedy. I'm with SoundHound. We're music recognition, search, and on your phones, basically, iPhones, on your Android phones. So we work in the space of music recognition is our main product, but realistically, we have Say Search also, so we do NLP. We do all the big buzzwords of big data there. So probably the real magic thing that we do that nobody else does that I've ever seen is we do sing hum search. So you can sing or hum and have the song recognized. And I've been at SoundHound for 1.5 years, and I still think it's magic. It's truly amazing. So, I've been there for 1.5 years, like I said, and in the big data area and kind of being the data hub and building out the team that's at the central point. And when I came there, we had a bunch of nice technical silos. So we were doing ML here, AI here, and it was all standalone silos. And so basically what I've been tasked with is building out the central point, which is like the data hub there, which is really interesting. So as opposed to doing machine learning stuff all day myself, I get to work with all the people who are doing the machine learning, and and folks on my team we're actually now starting to use that on the hub itself. So hopefully we can add value on the round trip of that. Before SoundHound, I've been at many startups. I was at Lookout Mobile Security, Linden Lab for many years, doing fraud detection with complex event processing. That was a lot of fun. Let's see, I was at Microsoft for 5 years. I was at Web TV, where we were acquired by Microsoft, and a bunch of startups with ex-Microsofties throughout the years. And in the 90s, Web 1.0, I had my own company doing billing and customer management software, which was actually quite fun because a lot of my clients went public and then tanked. It was quite exciting to see. The usual cycle. And then before that, I was at CSU Sacramento. I went there because I had a triple major. I was an electrical engineer, computer science, and neuroscience. And I didn't finish the electrical engineering. That was like the boring one. Yeah, so, and the reason I went there to CSU Sacramento was because it was the one place I could figure I could afford, because I'd been a traveling working musician for 5 years, playing keys, bass, and guitar. And I already knew what it was to starve, so I knew what it meant to live cheaply. So.
Are we going to talk about the musical instruments that the other panelists play? I play guitar. You wanna?
I play guitar, not well. I wouldn't call myself a musician, but I certainly love to pick it up and still just strum around every now and then. But yeah.
Oscar?
I used to play guitar.
So,
I play a mean air guitar. I play much better air than the real.
so as current or former musicians, we can all say that we're qualified to speak here. Okay?
I need to test my guitar skills.
So, you can do it afterward. Okay. So, Pashu was courteous enough to share my article on deep learning, and actually I had a really great time speaking with Eric about this subject. My thesis, if you didn't read the article, which I'm sure you will if you haven't already, is that over time, this will become a supplement for whether you're having musicologists pick up characteristics and write down or type in which ones they observe, or whether you're using machine listening techniques that have been in place for 10 years or something like that. So the Echo Nest has been doing that for a while. In addition to that, they do text analysis. And my learning after speaking with Tristan Jehan, co-founder of the Echo Nest, is, he wants to give it a try. And I also heard that, there are people at Google and Spotify who are also working on this. And Oscar, you were nice enough to point out that also at Ardio, people are looking into this. So maybe my opener is to have you guys comment on my article and see if you can tell me. Did you read it? Or comment on the synopsis of the article and tell me if you think there is any value to trying out this technique and what obstacles might lie in the way, and also what advantages might be there.
I did my homework, so I read your article.
Oh, perfect.
Yes. So, okay, deep learning. How many people know what's deep learning? Raise your hand. Okay. Deep learning, maybe like half people know. So deep learning is one of these buzzwords now in machine learning, but it's nothing more, at least my opinion, is that nothing more than classic neural networks from the 80s, convolutional neural networks, but that really were forgotten for a few years, and now given all the all the big data and all the processing power that we have, now it's become like useful again. But it's nothing new in terms of algorithms or machine learning. It's something that we're recycling from the 80s, and yeah, it was interesting back then, and now, well, even especially as I said, the data processing power, we're reusing it now. So my take on deep learning, yeah, I mean, Eric Schmidt, you interview Eric Schmidt, that's data science here. Yeah, I think he had good points on mentioning that. If you're interested in that, he did his PhD on deep learning to detect music emotion, music mood, so complex things to extract from the music that deep learning helped. But it was one tool, and he used many more.
You guys have like 50 plus recommenders, is what I understand.
Yeah.
It's a lot.
And deep learning is not one of them.
Right. Not yet.
No. So, okay, deep learning. So it's a very complex thing. I would say that, at least nowadays, deep learning is kind of a luxury. So you mentioned Google is using that. Well, Google has the power to buy 100,000 GPUs and try things. But my take on that is that if you're a startup or you're doing things, start simple. Start with many other machine learning simple approaches, logistic regression or decision trees, things that are much more simple. Well, there's a lot of details here, like linearity, non-linearity of the data, but start simple, and only if you not notice there's some lack of the results, that the accuracy is not good enough, or users are not satisfied, then move to the next step and do more complex stuff. But and that's the approach we follow here. I mean, we start with simple things. We have this awesome data that the curators and the music analysts have been annotating for the last 14 years, and we don't feel the need yet to go to complex stuff because our rich data allow us to create simple models with very good accuracy. So it's kind of a trade-off. You have lack of data, okay, you kind of create or try complex algorithms in order to overcome this limitation. But in our case, we have this rich amount of data that no one else has, and we have the luxury of trying simple things that are faster and easy to implement, and then get very high accuracy. But of course, we have experts here. We know that's state of the art. We're interested on that, but my take on that is that it's more like a luxury nowadays.
Okay, I'm actually going to just follow up before we hear from Jennifer. Is there any advantage to surfacing new music that a bot could find similar to an existing song, a query song, rather than waiting some time before a music analyst might actually come across and annotate a song? How long does it take, by the way?
Okay, questions. The first one is, yeah, we use the human part to process and analyze music, but we also do what we call machine listening. That you create this new term on your article about deep listening.
Yep.
So yeah, we do machine listening, and that means that we have these 1.5 million songs deeply, very much accurate, annotated, and then we apply machines and we scale that, and then we can, not as accurate as humans, but we can get like a good prediction of whether there's like a female voice here, there's like an electric guitar, and then these, as I said, not as accurate as humans, but still this representation by the machines give us a good estimate of what song will be similar to this one. So yeah, we use humans, we explore new genres, then we train humans, annotate that, and then we use machines to scale this process.
So
and then how long it takes?
exactly.
So yeah, I would say that on average 5 to 10 minutes. For classical music, it takes more time.
No, but if we were to all go into the recording studio here, and we were to record a great song.
We miss a bass guitar, like 3 guitars.
Okay, that's okay. That's okay. It'll throw off your system, but whatever. I think. How long would it take before the musicologists are going to get around to going over that? Or how long would it take then for the machine listening to happen?
Well, the first thing is that if we're a crappy band, first there's music curation that wouldn't allow to ingest the music to Pandora. So first thing is that we have the music curation, we have also a semi-automatic way to ingest music from record labels that are approved, and using some DDEX and some format. But we also have human curation team that any garage band can submit your music here, and then they listen to it, and then listen very carefully, and then they decide whether that song is a good fit for the radio format that Pandora follows. So we are not like other, there's a lot of on-demand services that they ingest everything, karaoke and background music that you can play your solo guitar, switch on mine on top of that. We don't have any of that. We have like select songs that are a good fit for this radio format. And then how long it takes, the whole process, I don't know exactly how many days, but it's like first curation team analyze that, then it goes to the pipeline. If it's approved, then to the human analyst that listen to that and annotate, and then it's ingested to the system.
So a few days.
Yeah.
Okay. And what if it's deep learning? How fast can we get it in there if it's some kind of multi-layer neural network?
Deep learning would be a substitute or an alternative for the machine listening part. So instead of using the current approach that we use, we can use deep learning to annotate the song. Like it's like a female singer, there's percussion. So that will be a replacement. Still, the human component for us is really important. So it will replace the machine listening part, but not the human.
Okay. So you have it here, ladies and gentlemen. Pandora will never disrupt its own aspect of using musicologists. Congratulations, guys.
You're welcome.
Okay. Jennifer, let's hear. I hear you have some AI sprinkled in there. So is there any deep learning going on in there?
Yeah, we actually had a conversation about this at work, and I read the article.
Okay,
Good
thank
article.
you. And you passed it, you shared it on Facebook and Twitter.
I didn't do that, but I did share it at work.
Do that later.
We did discuss it. But it's an interesting thing. We kind of do a little bit of, I would say, baby deep learning. And the reason for it is we actually use it to solve a very specific problem. It was persnickety problems with acoustic modeling. We have our own voice engine. We do a lot of homegrown things, since we have our own speech engine for say search. And making an exponential improvement, we kind of hit the wall. And so it was an effort on one person's part. He did a really bang-up job, but it's his love of this area that really brought it to fruition. But after a lot of effort, he actually got it to the point where it truly was an exponential improvement in acoustic modeling. So it did bump up what will be coming out in improved say search and voice recognition. But like I say, it was very solving a particular problem where just using standard techniques. Now we haven't necessarily tried to take it out in the rest of the areas, but it is interesting since we have it. It's a tool in our tool bag, so one could picture using it in other places. I in particular am a little greedy on that, so who knows? We might be able to roll it out and solve other problems. But as it goes, just as a point, I think the folks who are making great strides, like Google, using this and such, it really is one of their secret sauces. So it behooves all of us to try and emulate that, I believe. That, you know, just having more awesome tools in your tool bag is a good thing.
And that one person who's doing the baby deep learning, does he have a baby GPU to work on?
That's an interesting topic. They started on the GPU side with it, and then he found a way to skip it, which was really awesome because there was a little bit of a pushback from the folks on the upside, you know, saying, do we really, really want to invest in this? And so we had a really good conversation about that, and I think it was his hard-headedness about it, and it actually proved correct. You know, he's an extremely awesome engineer, and so he kept at it, and it really was quite an improvement. Now, I personally believe GPU processing for this type of thing is a huge win. So it is possible that as we move down the path, we might move it to GPU and that. But that's a big effort, and that takes a step beyond normal day-to-day engineering. You know, if we can carve off enough resources to do that.
And then I'm just going to follow up by saying that SoundHound, what people got to know SoundHound on was the mobile phone, just like you said, the iOS, the Android. And one thing that, as far as I know about mobile phones, I don't cover mobile, so I'm an idiot when it comes to this, is there are GPUs on phones. And there's a crazy startup I read about, not on VentureBeat for whatever reason, but it was in a different blog that I won't name here, that basically wanted to do the inference on the phone's GPU. Not the training, because that requires a lot more infrastructure and maybe data. But in terms of once a model has been trained, you can start to throw it on a phone. And that could be for voice recognition, or that could be for song recognition, dare I say. So I just wonder if there's any, do you expect for that to eventually go to the phone?
I actually do. And just, that's a little more personal take, because this is more of a lunchtime conversation. We were all talking about it. When you really think about, you know, the Internet of Things, when you've got processors in your cars, and you fill in the number of devices you can have beyond mobile phones, it's functionally going to be very similar to the mobile phone as far as what you have available to you. And having the GPU there for that kind of thing, that's huge. So it is definitely a possibility. And it's definitely a strong lunchtime conversation, is how I would put it right now.
Okay. Lunch means let's talk about it later, right?
Yeah.
All right. Got it. Okay. So I also want to make sure that we hit on the infrastructure layer, not just talking about the buzzword du jour. Actually, how many of you guys were watching the reInvent live stream for Amazon Web Services? Okay. Did you hear that there was a guy from Philips who said, hey, you can do some deep learning on all of this data? And I was about to break out my beer from the fridge and start having a drinking game to see how many times people can mention deep learning at the AWS keynote. But I didn't do that because that was the only reference. But at least it's there. So anyway, I wanted to talk about infrastructure and say, in terms of what people are running to store their massive amounts of different kinds of data, I understand, Jennifer, that you like Spark a lot. And I understand, Oscar, that you might also have some sympathies to Spark as well. So let's just talk about the transition among some companies from Hadoop and Hive to the Spark ecosystem, and where that makes sense and where maybe it's not quite ready for production grade workloads. I think this is not for every company, but it's definitely something people are considering and looking into.
Want to start?
Yes, so yeah, we do use Spark. So I think it's a nice combination, depending on the problem or the use case you're trying to solve. Hadoop or HDFS, Hadoop, Hive is a nice stack. We moved some of our jobs from Hadoop to Spark, mainly because they were like very memory intensive. You can imagine that, you know, we have a lot of millions of songs, then you need to load a matrix and compute some similarities there, And then we were doing that on Hadoop, so the I/O was really, the latency was very high. So we moved some of these jobs into Spark, where you have this, I'm not really expert, really RDD and the broadcasting. So you can, so the like one node and all the workers are sharing the same matrix, and then you can distribute the computation. So yeah, we do use Spark when we think it's needed, but we still do, we still use a lot Hadoop and Hive for analytics, for a lot of, so many reasons. But we're really interested in Spark. We're very happy with the results. These jobs were taking hours because, of course, Hadoop, is a shared resource, so many people from the company are using it. Now Spark is more new thing, not that many, it's not overloaded. So but anyway, in any case, we moved these jobs from Hadoop to Spark, and it moved from hours to minutes. So it was a big win for us.
Okay.
For us, we have a lot of MapReduce stuff out there, custom MapReduce, a lot of Hive, and unfortunately, because of the processing loads on the main cluster, it was stacking up, so our daily processing was growing and growing, and so we needed to improve that one way or another. And just throwing more hardware at it is kind of a more expensive solution. So Spark has been our way we're attacking that. And so by moving things off of Hive and all our custom MapReduce into Spark, we're able to reduce our processing loads, the times, a lot of the effort of keeping things in the processes as they're running instead of landing it stepwise to disk to disk. It's kind of moving piles of rocks, as I've always called it. And Spark allows you to get away from that model.